All right, so oh, I was trying to type something and it didn't type in the right. Could be a little bit challenging because when we say rational expressions, which is what the whole chapter is about, that's essentially what we called at the beginning a rational expression is a fraction. A fraction and a rational expression are essentially the same thing, because a rational number is a number that can be written as a fraction. Now, of course, when we're talking about rational expressions, we're talking about algebraic. In other words, now we're going to bring in those polynomials and such, primarily trinomials and trinomials where we have to factor. That'll be binomials, and then we can simplify them. All right, so let me just kind of show you something to just show you how all this fits in with the concept of fractions. If we have 5 over 25, that's what we call an unsimplified fraction, because we can write this as 1 times 5 and 5 times 5. And we can take out the common factor of 5. And so this right here is 1/5 in the skies, essentially. It's unsimplified version of 1/5. So all these things have to be simplified because that's just what's always expected, that you write things in simplified form. All right, now on 7.1, we got to bring up this thing before we simplify them. As a matter of fact, let's see here. See, this right here is the denominator. You remember that what we said about this? All right, because that's what we call undefined. So we can't have a 0 down there. Now, in this particular case, we've got x squared minus 25. So what we need to do is we need to find out, first of all, when that expression is equal to 0. And that's pretty easy to do because that's really what we did in the second to last section of chapter 6. Yeah, chapter 6. All right, and how do we do that? Well, remember chapter 5, we started talking about multiplying polynomials, and then in chapter 6 we factored them, and so we're going to use that information. And this one right here, it's called a special form, that x squared minus 25. The way I showed you that you can factor it in chapter 6 was just realize that what's missing is the x term, so you have 0 x's. So you're looking for numbers that multiply out to be 5, and since this is negative, they got to be different signs, and so they add up to be 0. Well, there's only two numbers that do that. There's x plus 5 and x minus 5. If you factor x squared minus 25, you get x plus 5 times x minus 5. All right, so that means when you set each one of these equal to 0, you get x is equal to negative 5 and x is equal to 5. So therefore, if x is equal to 5 or x is equal to negative 5, we got a problem. So we need to know this right here before we simplify, because we need to know if these things are, because what we're looking for is essentially values that are going to be solutions later on. So 5 and -5 give us 0. In other words, if we take 5 and square it, we got 25. 25 minus 0 is a no-no. -5 times -5 is also 25. And that gives us 0 as well, because 25 minus 25 is 0. Now that we got that, because that's one of the things they're going to ask you, is find any number or numbers for which the rational expression is undefined. Then simplify. Now we've done that. Now we're going to do the simplify. The simplify is paramount to what we did up here. We have to be able to factor this. Most people don't do it by factoring because they can just kind of see that there's a common factor of 5. 5 goes into 25 5 times and 5 into itself once. Generally with the polynomials, trinomials, binomials, it's hard to see that unless you factor them. All right, so here we got that expression. And the denominator, we already factored it up here. So we're just going to write the factors of x minus 5 and x plus 5. Now, essentially what's happening here is x plus 5 over x plus 5 is 1. And that's why they have that little 1 there. That's not an exponent. It's just that they're trying to show that that's 1. So in the denominator, all you have is x minus 5, and that's nuts. Let me kind of take that out to kind of make that where it's not so confusing. It looks like it's something when it's not supposed to be anything. It's just x minus 5. It's all that's left down there. And in the numerator is just 1. So it's 1 over x minus 5 is the simplified expression. Now, the reason why we factored this first is so we could see what these values were that made it undefined. Because if you see down here, once we simplify it, we don't have the x plus 5 anymore. So we don't know that next x minus 5, x is equal to -5, is going to give us an issue. Because the only thing we can see now is that 5 makes it undefined. So that's why we have to do that before we simplify. So there's the simplified expression. All right, well, I'm going to give you a couple of minutes to work on that first one. The numerator is all you need to factor. So go ahead and, oops. Go ahead and factor that numerator and see if you can simplify it. Okay, good, Christiana. All right, so let's just look at how that works. All right, so the numerator factors as x minus 4 times x plus 4. They putting these in there because they figure these are the easier ones to factor. All right, so first of all, we got to answer this question here. All right, so I'm going to do that up here. X plus 5, I'm sorry, x plus 4. And this is the way I do it. I just put a not equal there, and then I'll just solve it like usual. So that just means that x cannot be equal to negative 4. All right, but all we got left is, I don't know, did I do something wrong? Because there's no x minus 4 in the denominator. It's an x plus 4. So what you got left is it's just x minus 4 over 1 or x minus 4. Check that, guys, and let's just make sure. All right. So does that look good there? X minus 4. Any questions about how it gets like that? All right. Now this down here, number 2, we'll give that a try. Just, yeah, because the 1 is on the bottom. In other words, this is gone. This is a 1, and this is a 1. So the only thing that's left is x minus 4 over 1, which is just x minus 4. Okay. All right. So look at that next one. First of all, okay, this is x plus 4. I'm sorry, x plus 7. I don't know why I'm still thinking about x plus 4. Okay, this is just x plus 7 times x plus 7 down there. All right. So they're both the same. So what can't be, we just have to remember that x plus 7 can't be equal to 0. So that means negative 7, negative 7. So x cannot be equal to negative 7. Now, once we do that, that's the answer to the first part. And that's just an equal sign with a slash through it. That's technically what that means, that it cannot be equal to that. All right. So what does this one simplify down to? Okay, in the numerator, it's x minus 7, x plus 7. And just remember down here, there's 2 of them. All right. So what does that simplify down to? Here you got an x plus 7 up at the top and 1 in the denominator, so it's just so this is the answer to the first part. That's the answer to the second part, okay? Look it down, see if you got any questions. All right. So again, this is going to be similar to this. It's just got different variables. It's just got a squared minus 25, which is the same thing as here. It was just x. So let's just put up here a minus 5, a plus 5, not equal to 0. So again, that's the same ones. A is not equal to 5, or a so there's our 2 answers to this one. That's what makes it undefined. Like I said, it's basically just the same one from here. It's just that instead of x, it's a. All right, so what happens when you simplify? Okay, in the denominator, it's again, we just did it up there. It's a minus 5. And this one up at the top, what does that factor as? Okay, up at the top, the only thing that's common to both is a 5a. All right, so this is not going to factor as two binomials. You're just taking out the greatest common factor. All right, 5a times a is 5a squared. 5a times 5 is 25a. Now we take out those. Well, let me know if you got any questions about it. I got give you a few seconds to look at it. But you can move on to the next one now. This one's going to be a bit of a pain in the neck to factor, but this one should be fairly easy. This is our first trinomial, and then the denominator is very much like what we just did in the numerator over here. So let me know if you take a whack at that. So this is the first one. What you got, Amori? What are you asking or saying? You talking about number 2? So just to kind of get you started on number 4, the first part about the undefined is 3x squared plus 27x is not equal to 0. So just solve that, and that'll tell you what makes it undefined. All right. Anybody come up with anything on number 4? It's just like what we did over here in the numerator. There's a greatest common factor, and it's 3x. and x plus 9. So 3x can't be equal to 0, which means x can't be equal to 0, which is pretty obvious. Since there's x's in both terms, you put a 0 in there, it's 0. And then the other one is x plus 9 can't be equal to 0. So x can't be equal to negative 9. Second part. All right, so then on this one, now what I might just tell you here, this is a kind of a little hint that'll help you. When you have these things, you need to factor like this, these expressions, and then we're going to see it in 7.2. Factor the easiest one. Like, for example, I factored this up. Well, if you factor the easiest one first, you can use the factors you have as a hint on how to factor the numerator, or the other one, I guess you could say. If you factor the numerator first and then the denominator, that'll be a hint to tell you how to factor the denominator. So what I'm looking for is an x plus 9 is one of the factors here. And you can see that plus 9 into negative 36 means x minus 4. So this one here, we had a hint. So those are gone. And yes, that's x minus 4 over 3x. And I mean, this is, it shouldn't be that big of an issue for you, but I have students that get up into like upper level classes where they use a graphing calculator, and just realize that it's important when you type it out like that. Let me just show you what I meant. You have to realize that technically that's what you're looking at. You're not dividing just the negative 4 by 3x. It's the x minus 4 by 3x. And to render it properly on a calculator or a computer, you got to let it know that. It's just important. All right, go ahead to number 6. Yeah, we'll skip this one for a second. This one should actually be last. Well, I'll tell you what. Go on to number 7, and then we'll come back to these two. All right, so down here, again, it's just for 7.1 where you have to tell them about the undefined. But we need to do that first. So those can't be equal to 0. So that ends up being x. Oh, so this is x minus 3, x minus 3. So it's just basically x can't be equal to 3. And you can see if you put a 3 in there, 3 squared is 9. And negative 6 times 3 is 18. So 9 and 9 is 18 minus 18 gives you 0. So that's the part. Do that first, since. And then 2, we've already got the factors so that we can rewrite this one. All right, so this is already factored in the numerator. Don't have to worry about that. So what happens on this one?
It's going to be 1.
Okay, there's going to be 1, but it's not completely 1, because you still have that. You had 2 of those down there.
Right. So it's going to be 1 over x subtract 3.
All right, great. Love it. So just take your time with these, because you don't want to move too fast. Because I do that kind of thing too, flip things in my head and think, well, it's just x minus, just 1, but it's 1 over x minus 3, okay? All right, so that's the second part. Now, go on to this next 2. Number 8. I think 8 should be the easiest one so far, if I remember correctly. The first part being 4x minus 8 can't be equal to 0. So when we solve it, so x can't be equal to 2, because if you got 2 times 4, you got 8. 8 minus 8 is 0. So that's the first part that makes it undefined. So now go ahead and factor it and see what you come up with. Factor it and simplify. Take out your common factors. So up here, and then down here, well, let's see, we can take out a 2 also. No, we can take out a 4. All right, now these aren't the same, so don't be tempted. So just take those out, because that next one has to be, it has to be factor the numerator. All right. That's x plus 4. X, I'm sorry. You know what? I messed up. This should be a 2. I'm sorry. Times 2 is 8. I'm sorry. And then this is x plus 2, x minus 2. All right. So now we just take out anything that's common from top to bottom. So that's just the x minus 2 there. But 2 over 4, 2 goes into 2 once and into here twice. So we've got x plus 2 over 2. That's all there is left. Because this is a common factor. Once this is factored, that's x minus 2, x plus 2. This one is 4 times x minus 2. So the x minus 2's go out. And then 2 over 4 is really just 1/2 in disguise. All right, any questions about that one? All right, now 9 should be really, really easy to factor. So try that and see what happens. Again, 4x minus 16 can't be equal to 0. So 4x cannot be equal to 16. So x cannot be equal to 4. Because if you have 4 times 4, you got 16. 16 minus 16 is going to make it 0. So that's the answer to the first part. Try to factor it and see what happens. Don't rush with it, because I had some of my best students before there was, I guess you would say, quickly and didn't pay attention. So what does number 9 simplify down to? All right, let's look at it. You might be right, Kristen, but I can't remember. So this is 3 times x minus 3, right? 3 times 3 goes into 3, x times 3 goes into -9, -3. I know it's going to be tempting, but you got to watch out. All right. So what can we simplify there? All right. So just in case you thought something was going to take out here, what do you see that can be taken out, Sean? I mean, I'm not trying to embarrass you or anything, but is there anything that's common there from top to bottom? I know every one of these other ones, you had a common factor, but on this one, there is nothing common between 3 and 4. There's nothing common between x minus 3 and x minus 4, right? So that's all you can do. That's the factored form. If they say to put it in a factored form, then that's it. But it would be the same thing as here. But you're still going to have to say what the denominator can equal to. All right. I think I might already have these done over here. Let's go over here and say the ones that we skipped. 5 and 6. All right. If you got any questions about any of those other ones, let me know. That's later on. That's not here. All right. So we did 4 already. So that's the same thing there. So any last questions about any of these?
That's true.
What's that? I didn't hear who it was that was talking. I don't know if you're talking to me or somebody else, because you know how the way this thing works. When you make noise in the background, it turns on your mic. All right. Well, let's go on over here because. All right. All right, so this one we got to go through all the rigmarole to factor it, because this is just one of those that's got the 6. It's got a number over here other than x squared, so we got to go 6 times -2, which is going to be hold on a second. Oh, you know what? I'm sorry. This is what I was telling you about, is do the denominator first because that's easier. 6 times 1. So the only two factors of 6 and 1, and it's +6, are 6 and 1. So they got to both be positive, because I'm sorry, they're both the same sign because this is positive. And so both of the signs have to be negative. That's from 6.34. So it ends up being -2, -3, because that's the only ones that add up to -5. So the denominator factors as such, taking that long way. So it ends up being 3x minus 1, 2x minus 1. Now, as I said, is you can go back through the process. Now that you know that one of your factors is 2x minus 1 up here, then you know that the other one is got to be 3x plus 2, because 2x times 3x gives you 6x, and -1 times +2 gives you the -2. So that's the gist of 6.3. So if you know about that trial and error, so with the help of this, you don't necessarily have to go through that long AC method every time. Anyway, so once you figure that out, that it's 3x plus 2, so this is just going to write that there so you don't think I skipped anything. So 3x plus 2, 2 times 2x minus 1 on the numerator, and the denominator is 3x minus 1 2x minus 1. The 2x minus 1s go out, and so all that's left is 3x plus 2 and 3x minus 1. So that's the simplified answer. But we still need to determine what these two things can't be. So 3x minus 1 can't be equal to 0, and 2x minus 1 can't be equal to 0. So that's what I have down here is. So if x is, if x is 1/3, then 3 times 1/3 is 1, minus 1 is 0. So there's that one. And the same thing over here. 1/2 times 2 gives you 0 when you subtract. So there you got it. Any questions about that? I mean, because that one, the main thing, that's why I wanted to go over this one towards the end rather than in the middle, because this is a particularly tough one to factor. Like I said, it's the 6.3/6.4 material, which is usually the stuff that gives people the hardest time in chapter 6. All right, now, number 6. Slightly different, and it's different than any of these other ones. Now, you can fix this a couple of different ways, but you'll notice up here that the y doesn't come first. It's got 49 minus y squared, 49 minus y squared. All right. Now, it may be kind of hard to see why I'm doing this, but I just know from experience that if I factor out a -1 or a negative sign, that's going to essentially allow me to turn these around, because the 49 is positive and the y squared is negative. So if I just take a negative sign out, it's y squared minus 49. And then in the denominator is the y minus 7. So the y minus 7 can't be equal to 0. So y is not equal to 7. So that's the first part. Now, as I said is here, once you turn this around by factoring out that negative sign, then you're going to have the negative, which is essentially a -1, y plus 7 times y minus 7. And then the y minus 7s go out, and you're left with negative y plus 7. You could also turn them back around if you wanted to. I don't think it's going to matter to my math lab, because this is the same thing as negative y minus 7. Well, you could write it like that. Like I said, I kind of pretend to like it like that myself. All right, any questions? All right, well, let's take a little break then, and I'll see you in a few minutes, and then we'll go on to 7.2. Now, the good thing about 7.2, you don't have to worry about the denominators thing, about finding out about what the denominator is equal to. Because these are multiplying, and so it's slightly different. We're not really simplifying them. But anyway, you can just kind of look at these two examples, and when we come back, we'll go through it. And there's about the same number of problems. Actually, there's even less, but these take a look. Yeah, there's the same amount, but these take a little bit more time. All right. So, all right. Now, 7.2 is called multiplication, but here. All right. So they put together multiplication and division because of the fact that division is multiplication by the reciprocal. So we can take care of two operations here in one. So the first one we'll look at is just multiplication. Now, if we just left things like they were here and multiply these out, these two binomials up there on either side, in other words, x squared minus 2x times x squared minus 25. I don't know if I've ever tried it, but it ends up being a mess. Same thing down in the denominator. You're going to have 9 terms down there, and then you may still have to factor anyway. So the smart money goes with factoring these things beforehand. And as I said, is start with the easiest one first, and then use the factors as clues to help you in the other ones. So right here is the easiest one, at least looks like to me. This one might not be too bad up here, if you realize that's x minus 5, x plus 5. But this one is just taking out the common factor of x. So x times x minus 2. Now, then you can use x minus 2 as your hint about how to factor the other ones. Now, x minus 2 is not going to go into 25, so it's not going to work there. But the 2 goes into negative 10 5 times, so there's your 5 right there, x plus 5. So this one right here factors as x plus 5 times x minus 2. And then you can use the x plus 5 as a hint. Well, if you don't recognize any of the other ones. So x plus 5 goes into negative 5, or it goes into x minus 25, x minus 5 times. All right, remember that's the difference of squares. Now you got an x minus 5 and an x plus 5. Well, this is going to be clearly two negative factors. I'm sorry, a negative or a difference. So that's x minus 5 times x minus 5. You can use that as a hint. Now that everything is a factor, now that everything is factored, we can go ahead and just cross out common factors, and that's what they do here. X plus 5 and x plus 5 go out. That's what that is. There's an x minus 2 up here and an x minus 2 there. As long as it's top to bottom and they're the same, you can take out any factors. And then over here, you got an x minus 5 in the numerator and x minus 5 down there. And then it's x over x minus 5. So that looks a lot simpler than if you were to go ahead and multiply these out, and you're going to have 4 terms up in the numerator, 4 times and 9 in the denominator, and you're going to have to figure out how to simplify it. I'd hate to even think about that. It might be easier than I think, but I don't think so. All right, any questions about that first example? Well, I don't know. I got my mute. My mute's not on. Can you hear me now? Okay, because there's no mute wasn't on. I made sure not to turn that on when I got back. So any questions about that first one? It's just a matter of factoring and taking out the common factors. And when you take out the common factors, there's nothing left to multiply. That's generally easier than if you were to try to multiply x squared minus 2x times x squared minus 25. You're still going to have to factor, but it just may not be pretty. And then down here, you're going to have 9 terms. You're going to have to combine them. And then again, you're still going to have to factor. So factor before you do anything, and then take out the common factors. And the only thing that's left is x over x minus 5. Any questions? All right, so all right, now the next one is division. And remember, division is multiplication by the reciprocal. So it first looks like this. That's x plus 4 over 1. You know, when you just have whole numbers or even variables that have nothing in the denominator, well, that's because that's this seen as 1. That's why we can consider this a rational expression, because it can be written as a fraction if we want to, like this, x plus 4 over 1. But before we divide, we have to take the reciprocal, because there is no division in mathematics, to be honest. Division is defined as multiplication by the reciprocal. All right, so now it's no longer division, it becomes multiplication, and then 1 over x plus 4. All right, so we can use this as a hint. Well, plus 4 goes into negative 20 minus 5 times, so that's x minus 5, x plus 4. And then the x plus 5 is already down there. Take anything out that's common. The only thing common is the x plus 4. Those are gone. And we have x minus 5 times 1, which is x minus 5. And in the denominator, it's x plus 5. All right, now in actuality, we've already done things similar to this in chapter 5. So see if you can figure this one out. Again, you can factor with the numbers if you want to, or you can just find out what the common factor is top to bottom. There's none on going down, and there's none, well, actually there are some going across here, and there's some going across. There's none going from top to bottom on the individual expressions. So see if you can do this one. I'll give you a bit of time. So 5 goes in here twice. And 5 goes in here 5 times. 9 goes into 18. It just could be there's a lag in the internet. Oops, let me try this again. Oops, I shouldn't have restarted that. I lost my. Anyways, that's so bad. All right, hopefully it's better, because that's about all I can do. Because you're gonna have to restart if you still having a problem. All right, so 10 is divisible by 5 2 times. In here it's 5 times. 9 goes into 18 twice and into itself once. Now here's the thing is, I'm going to kind of handle it step by step. So this ends up being 2, because it's still got the x cubed and the x squared there. And then down here I got x squared, y squared times 5x. All right, and just to make it simplify, I'm going to go ahead and multiply that now, because it's going to be easier to see the x's and y's that are going to come out. So that's 4 x cubed y, and like I said, if you take these things out before, it's not nearly so complicated. It's x squared, what's 5 x squared times x is x cubed, and then y squared. All right, now the x cubed and the x cubed are gone, and one of the y's is gone. So up in the top, you just got 4, and you got 5y. Now, technically, this is where we started seeing this is in chapter 5. It's a little bit more complicated, but that's all we're doing for all of these things. All right, just simplifying them down. As I said, is if you take care of taking out the common factors first, there's not anything really left to do. Up there, there's just a 4, and down here, there's just a 5y left. So on this one here, factor it out. So that's 10. And then this is going to be, you can take out a 2 there. and then that's an x minus 3. So x minus 3's are gone. And then up here you got 5 times 3x, so that's 15x. And then there's going to be another. I guess you know what I should have done. Let me back up. It doesn't really matter. You could do it, but anyway, 5 goes into 5 one time and into there twice. So now again, there's not so much multiplying to do. So there's just 3x up there. So as you go through these, if you take the common factors out first, there's generally not much left to multiply. There's 2 times 2 is 4. Because remember, the 5 goes into the 10 twice. And there's nothing else left. 2 times 2. All right, try that number 3. Factoring it. I may have to go on the board over here. I think I may already even have it worked out, but I want y'all to look at it a bit. Because it seems like it's hard to squeeze that one in there. Yeah, that's it. Okay. All right, let me know if you can find anything else. Now, one of the things you can do first is common factors going across, then factor each of this one and that one. All right. So, as I said, take advantage of things going across like that. So 3 goes into 15 5 times, so that's the 1 down there. And then all you got left is 5y here. So what I did is I put it up front. And then this one right here factors as, oh, I'm sorry, no, I didn't put it up front. This is the factor of, that's the greatest common factor on this side. It's 5y times y minus 3. And then this is the 5y that's there. All right, so now here's, you just left the y squared, and then you can factor out a 2 to give you 2 times y minus 3. The y minus 3's go out. And then you're left with 5y times 5y, which is 25y squared. And then you got 2 times y squared here. The y squareds are gone, so it's just 25 over 2. All right, questions about that one, number 3? So there's nothing common between 25 and 2, so it stays like that. So you see how most of these, all of them simplify down to something very simple without having to do any multiplication. Because even in actuality, if I had wanted to, I could have taken out, a y here, because that's y squared right there. So at some point I could have taken those y's out because that's y squared there. So it's going to come out at some point. I just multiplied it to make it easy to see for showing you. All right, so 4 is going to be completely factoring these polynomials. So thankfully, there's not any real tough ones to factor here like they had. This is the last multiplication, so y'all give that a try. I'm going to wait here until I see somebody say something about it. Because it's going to take a while to factor. As I had said, is use the simplest terms to help you factor. This one right here looks like to be the easiest one to factor because that's just an x times x minus 7. So this is going to be x plus and x minus something. All right, so this is x times x minus 7. All right, that's all being multiplied. So this is just a plain old x squared. You can use it to take out this x if you want to. You don't have to do it right away. But we got an x minus 7. That gives us a hint. This one right here is, oops, this is, why did I put a 1 there? That's going to be 3. This is x plus 7. That's x minus 3. There we go. So again, this is x plus 7, x minus 7. All right, so how can that simplify down? Well, those are gone. Those are gone. And there's 2 x's here, x squared. So this is just going to be 1x. That one's gone. So all I'm left with in the numerator is x minus 7. And down here is just an x. Okay. So see, all the rest of these are division. So it's essential that the second expression get turned upside down. All right. This right here, again, is a hint to help you with this. So it's x plus 5. So what gives you what you need? You need an x minus 5 down there. So what do we simplify down to there? What can come out? Anything top to bottom that's the same goes away. This is x is gone with just a 1 there, and there's only one x there left. So up here, there's just 1, and then there's an x times an x minus 5. All right, questions about that one? All the rest of these are division, so we got them all. Take the reciprocal. Let's see what. So this is the same kind of thing we keep getting. It's one of these difference of squares. I'm just going to go ahead and do it. All right, so we're going to multiply by the reciprocal. So that's x plus 6 over 1. So we're going to do 1 over x plus 6. Those are gone. All we got left is x minus 6. All right, any questions? All right, so again, this is the first one always stays the same. You don't ever want to flip that one. All right. So again, use, that's a multiplication sign. Use one that's already factored to help you. This right here is a trinomial. So most likely x plus 2 is going to be a factor, and it is. So that's x plus 1 times x plus 2 times x plus 2 over x squared. One of those is gone, and one of these is gone. Well, that one's gone, and there's one of those gone. So everything that's left is 1 over x plus 1. All right, and just keep in mind that this next test is just a little over a week away. All right, like 9 days. And you got to start early on this stuff because you want to be able to go through these things, see what questions you got, and bring them back. Back to what? On that problem or another one? Well, Sean, I'm saying. All right, well, it's division, so we got to multiply by the reciprocal. See how they change spots? See, the numerator is the denominator, and the denominator is the numerator. And the only thing that really needed to be done was factor this one right here. And 2, they all got to be positive. 2 only has a factor of 1 and 2. So this one was a hint. So x plus 2 times x plus 1. These here are gone. And one of the x's is gone. That x right there stays. This one is just a 1. So the only thing that's left is 1 over x plus 1. Does that answer the question, or was there something specific? Okay, so this one, the good thing about this is going to be the toughest one because it's for trinomials. But this one right here, it's got, these are the easy ones to factor. It's just the greatest common factor. But remember, this part doesn't change. The first term, and I could probably factor these just from experience, but I'm going to show you how you can use so see that? It's division. So to be multiplication, we take the reciprocal. Just flip it upside down, in other words. All right, so I'm going to factor this side because that's just got a greatest common factor. Greatest common factor of 2 to the x plus 4. 2 goes into 2x, x times 2 goes into 8 4 times. Now I'm going to use these as a hint. And as I said is, for the denominator, I'm looking for an x minus 3. Negative 3 goes into positive 9, negative 3 times. So these are both x minus 3. X minus 3 times x minus 3. You can go through the whole process of factoring it like we did in chapter 6, but as I had said I just use go through the full process if I don't have any hint about what to go on. But this one's providing a hint that x minus 3 is going to be one of the factors, and lo and behold, it is, and that's x minus 3 times x minus 3. So I'm looking for an x plus 4 into 16 goes plus 4 times. So that's also one just like this. It's what they call the sum of squares. It's x plus 4 squared, but I'm going to write it out twice. And then just take out the common factors. Those are gone. Oops. The 3 is still there. All right, so these are both gone. These are both gone, and I got a 3 and a 2 there. So all that's left here is a 3/2. So I'm just going to put it in front. And you'll see there's nothing else we can take out at that point. All right, so try number 9, not be to get out of the class. It's pretty much factoring just like any of these other ones. It's just that you got 4. Start with the easiest one, the one that looks the simplest. Like this one right here, x squared minus x minus 12. Well, that's one we keep running into because that's that x minus 3. I'm sorry, x plus 3, x minus 4 thing. So first thing is you got to remember to turn it upside down. Most likely, if you don't do that and you try to factor them, you probably won't have much drop out because these are designed to simplify when it's multiplying. Oops. See, I almost wrote it just like it is. You got to turn it upside down. All right, so whichever one you want to start with, like I said, is this one right here. Seems pretty easy to me, that one, because that's a pretty common one. That's x minus 4 times x plus 3. Because you got negative 4 times 3 gives you negative 12. Negative 4 plus 3 gives you negative 1x. All right. Now I'm going to use that as a hint on this one right down here, because this one's still down there. 3 goes into 15 5 times. So this is x plus 5, x plus 3. All right. And then again, whichever one looks the easiest. This one right here, it's got to be 2 different signs. There's only 2 factors of 10 that have a difference of 3. So that's x plus 5 and x minus 2. And then again, look for those things here that you've just factored to help you. So 8 is divisible by 2. So negative 2 goes into positive 8, negative 4 times. So negative 4. And then just take out the common factors. And almost everything's gone except for, hold on a second. Did I get that right? Looks like everything's coming out. Because 5 times 3 is 15. 5 plus 3 is 8. This is negative 4 times positive 3 to give negative 12, and the difference is negative 1. This is negative 4 times negative 2 is positive 8. Negative 4 and negative 2 is negative 6, so that's right. What about this one? Oh, this is 5. I'm sorry. I'm just thinking it's a 3. So that's a 5. So not everything's leaving. No, yeah, there is. Because that's 5 minus 2 is 3. So this whole thing is equal to 1. All right. So any questions?